Activity 14.2 is probability with coins. To make things easy, you can just use one coin. I'll also show you the virtual version. So on a coin, you have heads or you have tails. Those are the two possible outcomes. So you can get heads or tails if you write it in brackets. There are two outcomes, and you have a 1 in 2 or 50-50 chance. If you toss it 2 times, we can list our sample space into a table. This works if you have two events that happen, rolling a pair of dice, flipping a coin 2 times. So you have heads, heads here, a heads, tails here, tails, heads, or tails, tails. So if you flip a fair coin 2 times, how many possible outcomes are there? 1, 2, 3, 4. There are 4. What is the probability it lands on tails both times? 1 out of 4. It's the bottom right here. What's the probability it lands on heads on the first flip and tails on the second flip? So heads, tails would be 1/4 again, because it's heads first, then tails. What's the probability it lands on heads once and tails once? If they don't specify the order, you need one head and one tail. So you have 2 different choices. Each of these is 1/4, or was adding, you get 2/4 simplified to 1/2. So pay attention if they specify the order or they don't. Okay, so now we're going to do an experiment for tossing your coin 3 times. So for each experiment, you toss it 3 times. If I were to do this with my coin, I would get tails, tails, and tails. I'm not very good at flipping them. I will show you the virtual version of this next. You will do this experiment 10 times. Okay, so for this one, you just click on flip, and it will put in for this one's heads, heads, heads. So you do this 10 times until your entire table is filled out. Then you transfer that data onto your sheet. Okay, so you have done this 10 times with either coin or you use the app I created. So these questions are all experimental probability questions, and they're all based on the table that you have. So we did 10 experiments. What's the probability of getting 3 tails? So this would be out of 10. Now, I didn't complete my table. I want you to do your own and not copy mine. But let's say I have no other row that shows tails, tails, tails. For this, I would show 1 out of 10. Yours will be different. What's the experimental probability of getting 0 tails? So that would be heads, heads, heads. It's going to be something out of 10 for you. What is the complement of getting 0 tails? So the complement is basically everything else in the sample space. So if you take the probability of an event and its complement, it should add up to 1, or in this example, 10 out of 10. So I want to get 0 tails. So let's say, for example, I'm making this number up, and for example, I have 3 out of 10. Then the complement would be 7 out of 10. Or it would be 1 minus the 3 out of 10. So if I had heads, heads, heads 3 times, which is 0 tails, the complement of that would be 7 over 10. So we can always do 1 minus whatever the complement is asking for. The complement of 0 tails, if 0 tails was 3 out of 10, the complement is going to be 1 minus that because it has to add up to 1. That's a complement. What is the experimental probability of tosses falling in this order? HTH. That's out of 10. In your table, how many times did you get heads, tails, heads? What's the experimental probability of getting 2 heads and 1 tail? Well, 2 heads and 1 tail could be heads, tails, heads, could be heads, heads, tails, and there's or in between these, or tails, heads, heads. Those are the different combinations you can have that would be getting 2 heads and 1 tail. So you can figure this out of 10 and add them together and get a probability out of 10. What is the experimental probability of getting at least 2 heads? So at least 2 heads is going to be 2 heads or 3 heads. 2 heads is exactly what you figured out. It's a different color over here. This is 2 heads. It's understood that the third one is going to be tails. So whatever you have here, that's the 2 heads. So write something down over 10, and 3 heads is your answer to B. So for B, right here, we have 3 heads. That is right here. That's going to be something out of 10 as well. And then you're going to add those together. Oops, equals, not plus. Add them together, get something out of 10. Okay, what's the experimental probability of getting at most 2 heads? So at most 2 heads would be 0 heads or 1 head or 2 heads. 0 heads would mean all tails. That's this one. So whatever you had over 10, different than my 1. 1 head, well, you're going to have to look in your table for that one. Just find all the ones that have 1 head, and then 2 heads is the one that you did in part E, something over 10. Sorry, it's running over into the bottom, but add them together to get something over 10. So that's based on your experiment. Next, we're going to see what the theoretical probability is. So another way of doing our sample space is what we call a probability tree. So in the first toss, you could have gotten heads, tails. After that, you still are equally likely to get heads or tails. After that, you can still get heads or tails. The way to read a probability tree is you follow the branches. So you go heads, heads, heads. That would be the outcome that goes here. Okay, this is heads, then tails, then heads. Heads, tails, tails. Tails, heads, head. Tails, head, tails. So I'm following the branches. Tails, tails, heads. Tails, tails, tails. Okay. Once we have that, we have 1, 2, 3, 4, 5, 6, 7, 8 outcomes. There are 8 possible outcomes. Oh, it's asking us to write it as a listing. So just write all your outcome down here in the curly brackets. A tree will keep you more organized, and it makes sure that you don't miss any. It's a little harder in a listing to know that you have them all. And how many ways can 3 tails occur? 1. There is a difference. Let me find my highlighter somewhere. I'm finding it for you. How many ways is different than asking for the theoretical probability? How many ways is just the number? Probability is going to be a fraction. So 3 tails would then be 1 out of 8. There's one way of getting it over the total number of outcomes, which was 8. In how many ways can you have 2 heads and 1 tail? So 2 heads was heads, heads, tails, or heads, tails, heads, or tails, heads, heads. There are 3 ways. The theoretical probability is going to be 3 out of 8 then. Again, it's asking for the how many ways and then the theoretical probability. What's the theoretical probability of getting at least 2 heads? So that's 2 H's or 3 H's. So I'm just going to look in my table, in my outcomes for this one, 2 heads or 3 tails. Well, I know 2 heads, there were 3 of those. 3 heads, there's 1. So that should be 4. So let's see. This one has 2 heads. This one has 2 heads. This one has 2 heads. Maybe I'm going to mark all the ones with 2 heads that have at least, 2 heads. 1, 2, 3, 4. Down here, I have 1, 2, 3, 4. If I want at most 2 heads, that was 0 heads, which is equal to 3 tails, or 1 head, or 2 heads. So let's do that one maybe in a different color. I want 0 heads is right here. All tails. 1 head, exactly 1 H. It's right here, and right here. Or 2 heads. Well, 2 heads is here, here, and here. Okay, well, if I add all of those together, I get 7 out of 8. That's in green. And I guess that makes sense because this would be the complement of 3 heads. 3 heads is 1 out of 8. Complement of that would be 7 out of 8. Next, it's going to ask us to compare your experimental probability versus theoretical. The experimental is out of 10. That's easier to put in percents than our theoretical. So I am going to convert these into percents. Oops, 37.5% is 50%. And this is 87.5%. Do the same on the previous page. Their fractions are over 10. Like I said, that's a bit easier to put into percents. So right here, we want to know how do the experimental probabilities compare to the theoretical probabilities? Well, for example, this is my example. I had tails, 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 ones, which is 1 out of 10. So if I make that into a percent, that would be 10%. Theoretically, the theoretical probability was 1 out of 8, which is 12.5%. So this is close. I would say if you're within a few percent, you're close. If there was a large difference, so for some of your probabilities, it could be pretty large difference. Why do you think this occurred? I would say, for example, we only did the experiment 10 times. That could explain a large difference. How would the theoretical and experimental probabilities compare if we performed the experiment 1,000 times instead of 10 times? The experimental and theoretical probabilities would be much closer. This is called the law of large numbers. The more times you perform an experiment, the closer you get to theoretical probability. Your individual penguin race probability was probably pretty far off from the theoretical, but the more people add data to the spreadsheet, the closer that will get to theoretical probability. Okay, without writing the outcomes, how many outcomes would there be if the fair coin was tossed 4 times? So one time you had 2 outcomes. So toss once, number of outcomes was 2. If you tossed it 2 times, we have 4. That's the one in the table. If we did it 3 times, that's our probability tree. We had 8. So I think 4 should then go to 16 if you follow the pattern. What would be the theoretical probability that all 4 flips would land on tails? Tails, tails, tails would be 1 out of 16. 16 outcomes, only 1 would have all tails. Without writing it, how many outcomes would there be if a fair coin was tossed 5 times? So what do you think this number would be for 5 times? And then what would be the theoretical probability that all 5 flips would land on tails? So go ahead and finish those notes.